Hello students, welcome once again to the 16th lecture on software engineering and project management. When we perform software project planning, various relative costs of different phases of software development need to be considered. Requirement analysis, design, coding, testing, integration and maintenance, all these phases involves cost. So in this class, we are trying to give you an introduction about the estimation models, empirical estimation models, and introduction part for the cost estimation. Even though there is ambiguities and confusions in the software development, when we do the estimation of software projects, it should be as much close to the real actual value. So we need to consider different estimation options. So normally the estimation is made, is planned till the last moment of the beginning of the project. Delay in estimation until late in the project is a normal practice to get the best estimation about the project. We know we can achieve 100% accuracy in the estimate if we complete the project, but it is not a practical one, as we all know. Another software project estimation option is we consider base estimates on similar projects that have already been completed. Then another aspect in the estimation option is use relatively simple decomposition techniques to generate project cost and effort estimates. There are several empirical models. So use one or more empirical models for software cost and effort estimation. All these things are different estimation options. Sometimes all these options will be taken together for estimate the project, or the possible types of estimations in these are taken for estimating the projects. Empirical estimation models for a software uses explicitly derived formulas to predict the effort as function of lines of code. We call it with short form LOC, or function point average FP, function point count. So these two are the major part when we do the empirical estimation models, line of code and function point. So let us discuss in detail about this line of code and function point before moving to the detailed learning of this empirical estimation models. So for empirical estimation, the size estimation can be based on line of code, LOC. The program shown here is a function for sorting an array. The program consists of 18 lines. Line of code is simply the count of the number of lines as shown in this figure. 18 is the line of code for this program. There are several ways of expressing line of code. When comments and blank lines are ignored, this program contains only 17 LOCs. Furthermore, if the main interest is the size of the program for specific functionality, it may be reasonable to include executable statements alone. The only executable statements in this program, in this figure, are in lines from line 5 to line 17, which is leading to the count of line of code as 13. The predominant definition for line of code used by researchers is: a line of code is any line of program text that is not a comment or blank line, regardless of the number of statements or fragments of statements on the line. This specifically includes all lines containing program header, declaration, and executable and non-executable statements. With this definition, this program has 17 line of codes. In software engineering, there will be thousands of lines of code. So normally LOC is measured in terms of KLOC, that is in terms of thousands of lines of code. In terms of thousands of lines of code, we measure the line of code in normal software engineering projects for computational purpose. Anyway, I hope you got the idea about line of code as a metric for the calculation of the project cost estimation. Another method or another data to predict the effort is as a function of function point in empirical estimation model. Alan Albrecht, while working for IBM, recognized the problem in size measurement in 1970s and developed a technique which is called function point analysis, which appeared to be a solution to the size measurement problem in the software development. The principle of Albrecht's function point analysis is that a system is decomposed into 5 functional units. They are input functional units, output functional units, enquiries functional units, internal logical files, external interface files. These 5 functional units can be categorized into 2 categories. One category is data function types. Second category is transactional functional types. Function points may compute the following important metrics: productivity matrix, which can be calculated with the unit as person months, function point per person months. Then quality can be calculated as the number of defects per function point. Then cost can be estimated with the unit rupees per function point. Then documentation, the important metrics can be estimated with the unit pages of documentation per function point. Anyway, these metrics are controversial and are not universally acceptable. There are standards issued by International Function Point User Group IFPUG and United Kingdom Function Point User Group UFPGU. An ISO standard for function point method is also being developed. A function point can be computed by multiplying unadjusted function points with the complexity adjustment factor. Complexity adjustment factor is based on 14 different factors like reusable code, complexity of code, critical nature, etc. A sample value of complexity adjustment factor is 1.2. So to calculate the function point, first we have to find UFP, that is unadjusted function point. So let us understand the procedure for the calculation of unadjusted function point. So as per the principle of Albert's function point analysis, the system is decomposed into 5 functional units. And these 5 functional units are given as external inputs EI, external outputs EO, external enquiries EQ, internal logic files ILF, and external interface files as EIF. Instead of just counting the function points, for these different functional units, we are assigning some weighting factors. The 3 possible weighting factors we have assigned are low weighting factor, average weighting factor, and high weighting factor. It means that if for designing the functional units of external input, if the weighting factor is low, that means that the function point of external input building is very easy, so that weighting factor can be a low value like 3. If we choose the weighting factor as high for external input function point design, then it means that it is not so simple. External input function point design is more complicated or difficult, so that the weighting factor is high. Like that, we assign the various values for these functional units. The procedure for the calculation of unadjusted function points in mathematical form is UFP is equal to sigma I is equal to 1 to 5, sigma j is equal to 1 to 3, Zij into Wij, where I indicates the row and j indicates the column of this table. Wij is the entry of the ith row and jth column of this table. Zij is the count of the number of functional units of type I that have been classified as having the complexity corresponding to column J. I hope when we do a problem, this calculation of unadjusted function points will be more clear. So let us do one problem now. Consider a project with the following functional units. Number of user inputs is 50. Number of user output is 40. Number of user enquiries is 35. Number of user files is 6. And number of external interfaces is 4. We need to compute the unadjusted function points for this project. Since the weights are not given, we assume that all weighting factors are average. In the previous slide, we know that the average weighting factors for external input is 4. Average weighting factor for external output is 5. Average weighting factor for enquiries is 4. Average weighting factor for logical files is 10. And average weighting factor for external interface file is 7. So we substitute these average values in the formula. UFP is equal to unadjusted function point is equal to 50 into 4 plus 40 into 5 plus 35 into 4 plus 6 into 10 plus 4 into 7, and it becomes 628. 628 is unadjusted function point. To get function point, we have to multiply unadjusted function point with the complexity adjustment factor. So actual function point is computed by multiplying UFP with CAF. Sometimes the value of CAF can be 1, sometimes it can be 1.2. So based on the given CAF value, the actual function points can be computed. I hope now you are more clear with the counting of function points. Let us do one more problem for better clarity. Example 2. An application has the following: 10 low external inputs, 12 high external outputs, 20 low internal logical files, 15 high external interface files, 12 average external enquiries, and a value of complexity adjustment factor of 1.10. What are the adjusted and unadjusted function point counts? So the solution is given with this formula. All the values are given in the question as done in the previous example. Substitute the value of Zi and Wij. The weighted average of some values are low, some values are of high weighted average. So take the approximate value from the table, substitute the value, and then after getting the unadjusted function point UFP, multiply with CAF. In the question it is given as CAF complexity adjustment factor value is 1.10. So multiply the UFP with 1.10, we will get the actual function point. Dear students, remember we are trying to estimate the cost for the software development. A number of estimation techniques have been developed and are having following attributes in common. Project scope must be established in advance. Software metrics are used as a basis from which estimates are made. The project is broken into small pieces which are estimated individually. Another important thing in cost estimation is that the cost estimation need to be achieved with reliable cost estimation, with reliable schedule. And there are a number of options arise for this purpose. This is a repeated point, but it is important, so I am repeating. Delay estimation until late in project. Use simple decomposition techniques to generate project cost and schedule estimates. Develop empirical models for estimation and acquire one or more automated estimation tools. So as part of identifying the cost estimation, we are going to develop empirical models for estimation. Empirical estimation models. We use empirically derived formulas to predict effort as a function of line of code or function point. An empirical model is based on experience, that is, historical data of previous project is taken, and it takes the form D is equal to function of Vi. where D is one of a number of estimated values such as effort, cost, project duration, and Vi are the selected independent parameters, for example, the estimated line of code or estimated function point, etc. Empirical estimation models can be of two types: static single variable models and static multivariable models. We will learn these models in the next class.